Greetings to all the audience, and thank you for bearing with me online. Today, I would like to present what I've entitled Building and Analyzing Digital Archives for Delving into Ecological Succession of Arctic Marine Lithophiles. And this time, I will focus more on the digital archives bit. However, the other terms in blue, I will also explain throughout my presentation. A little bit of intro about my PhD workflow. Everything started what I called ecological data extraction pipeline. All of these pipelines started with image acquisition by my supervisor in the Arctic. However, I've been also acquiring my own images at the lab conditions, at the lab, and I will describe them further on. All these images they go into a loop of pre-processing and image processing to be analyzed, and then gather some data, interpret it, after we have the results. But of course, the last goal is to do some data management of this, thinking always about fair principles. So a bit of info on fairness. When I say fair, referring to the principles of findability, accessibility, interoperability, and reusability. And in the marine imaging community, Shunin et al. In 2022 published this article where they suggest that standardized formats and procedures are needed to enable sustainable image analysis and processing tools, as are solutions for image publications in long-term repositories to a certain reuse of data. The FAIR principles provide a framework for such data management goals. And so one of the goals of my PhD is to create these IFDOs, so image fair digital objects. Back to experimental constructions. My supervisor installed many years ago these constructions, and he photographed them at least once per year. He took images of different regions of each plate, sometimes 4 subplates, sometimes 6 subplates. And then what I had to do during the first bit of my PhD was to process them. What I called the photo merging extravaganza, because I was dealing with a lot of images, and I had to merge them and create these photo mosaics. And after that, I had to make some kind of inventory so I can revisit it and see where I was struggling a little bit, which one of those plates needed more processing or enhancement of squaring or anchoring. It's just to have a list of and record the progress. So the historical tracking of the underwater imagery, here we can see the succession of one of the plates. It's the same plate throughout 9 years. The year 1 in the top left, all to 9 years in the bottom right. And here an animation of it. You can see how the coverage changes, how the three-dimensional organisms also start growing, and some of them start falling off. So you can see the development here. There's a story to tell already by looking at this. So the photomosaicing, the squaring, and the anchoring were taken for me as tenets for this historical tracking. And I wanted to show you a record of one of the plates. Here's one of the underwater images. And I'm zooming in, but as you can see, the edges are not square. So ideally, they should be a square, because I was working with a square plate of 15 by 15 centimeters. So first step was to do some transformations of the edges. But once this was done, here is the product. And then that's 1 year, 1 plate. let's say one replica. And you can see the very bits of the subplates composing this whole photomosaic. So I loaded all the photomosaics of the very single plate through the years in one huge file, which is the one we are looking here. And I need to focus on the very 10 by 10 square, internal square. Um, so I need to anchor and take a reference point that has been fairly consistent throughout the whole history of the plate and use it as a reference to anchor to anchor my plate. So in this case, I use a barnacle to do that. And after I anchor every single plate to a reference point, I have the whole history of that plate. And I put it on a single file from which I can then analyze. So here you can see a comparison side to side of the underwater taken in situ in the Arctic versus the one I took at the lab. Is the very same plate, just 1 year difference. And I zoom in into the yellow rectangle, and you can see we can see already some differences on the performance of the procedure. On the left, you can see, forget about the white balance because I haven't done that process yet. I haven't white balanced it yet. But you can see the focus, the degree of focus or the sharpness of the image. On the left is poorer than on the right. You can see that it's sharper on the right, and you can see more details on the right. That's because I had more time to photograph this and to manipulate some conditions. I would like to tell you how I did it. Another zoom in, also underwater on the left and with lab conditions on the right. You can see that on the right, not only the very bottom layer is focused, but also the very top one com compared to the one on the left, where the bottom layer is kind of focused, but the top layer is not. So although you can do this with very fancy equipment, I arm myself with a Leica microscope, a casserole where I put the plate, I submerge it in water, and a set of LED lights, one ring one, and another one with which is a diving light. And also I use this gridded frame to provide some reference. And this is what the gridded frame looked like. And I thought it might be very interesting to be able to go back to the very same region of interest if I have any question or if I need to revisit that very same grid, which I actually do. And I came up with this coordinate system. Since the internal square is 10 by 10 centimeters, I divided one grid per centimeter, and I provided these negative values. So uh, I read the x-axis first and then the y-axis. So in the case of the yellow point, it will be a -2, 4. The green one will be -3, 2. And the gray one will be 5, -5. And I actually needed this coordinate system because I had to revisit all the grids that were colonized by three-dimensional organisms, or the organisms that look more like bushes. Because once I removed them, I had to count whatever was living or growing in the very bottom layer of this grid. And also I can ask some questions and put them on my lab sheet so I can keep track of all these queries. So here you can see the bushes. And what I'm doing here is one single instance An instance is this very same region, this very same region of interest. You will see different focus in the next slide. Here I'm focusing the very bottom layer of the plate. Here I'm focusing the middle layer. And here I'm focusing the top layer. So you can see the branches of the top left, on the bottom left, very well focused in this last one. So I did that 3 different focus per instance. So I had to do 5 horizontal instances and 7 vertical instances, thinking always about achieving at least 40% overlap between each neighbor image. So at the end, I will have 105 images per plate. And I could work these very fancy high resolution um, files. I would also like to focus a little bit on the importance of definitions. At the very beginning, I was using rock encrusting as a synonym for lithophiles. However, rock encrusting organisms could be and might be confused with the attribution of different growth forms as encrusting growth form. Therefore, I thought it would be more general and more clear to use lithophile or lithophilic assemblages, more appropriate, I would say. Because you can see on the right different growth forms. This is a review that I had to do a while ago. And you can see different growth forms and different geometries of growth. So on the top, you see the encrusting one, the real encrusting ones. And then you see erect, rigid, erect, flexible, and erect, robust. So to say rock encrusting, not because it's encrusting, not because it's living in top of a rock, makes these organisms a rock encrusting organism necessarily. So I'm starting to use this new terminology for substrate dwellers, uh, proposed by Taylor and Wilson. And to all animals living on top of a rock will be a epilithozoan. And to any animal using another animal as substrate will be a epizoozoan. So on the left, you now can see lithophiles, so organisms that usually grow on top of rocks, lithophiles. And these happen to be true rock encrusting epilithozoans, because these have the growth form of encrusting, of crusts. And you can see some images here, and one of the most common in my plates, the tegela. But what about the erect, flexible organisms? This also provide a secondary habitat, a secondary the substrate to other organisms. And those are precisely the ones that I have been removing and counting separately. Here you can see different organisms colonizing, are using this Dendrobeania genus as a secondary substrate. And you can see some scanning electro microphotographs on the very far right. Foraminiferans on the top and spirorbit worms on the bottom. This will be the epizoozoans. These are animals living on top of other animals. And this is important because once I remove them from my plates and I started counting them, there's a huge difference. So on the left, you can see is an average of the replicates found in the site number 1 in the shallows, and the other one is farther deep at 13 meters of the very same site. But you can see that like the abundance of organisms is between 350 and 600. However, when we include the count of those animals colonizing other animals, like the epizoans, you can see that the number just boosts. So it's very important to consider this secondary substrate provision. Almost coming to an end, I would like to show you how I work this focus stacking. So I first need to select all the files that I want to stack. And this very same procedure I've done with the uh, focus stacking of all my instances of the plate. But I'm also doing this to photograph all these episodes on. So it's the same procedure, just different object. Um, so now that the layers have been loaded, I just need to blend them and stack them. And you will see in few seconds how all the frame becomes sharper because it's using the best focused pixels to create this focus stack image. And that's exactly what I did with the plates. So I'm almost burying myself with all these digital files. I need to be very organized. And once I process all the images and I relabel them and I create the metadata, the idea is to come up with a method paper describing all these methods that I briefly described to you, and also provide a data descriptor because to describe what was the experimental setup in situ in the Arctic and also the experimental setup in the lab. The other important thing is to come up thinking about the IFDOs, is the metadata repository, which I've used already for a data paper published this year, is the EOPangeo network, because this is part of the standards required by the scientific community, is to provide the metadata and make it available. And it's also one of the, is following the FAIR principles, all these tenets. And then if I have used any code, any special code, um, it will be necessary um, to share it also. If create, store, and manage, and share any code, I will be using GitHub. All this is thinking of sharing all this science. And that will be it for me now. Unfortunately, I'm not in presence to answer any questions. However, if you are interested or have any important questions to ask, you can send me an email. Thanks for your attention.